Section 410 talks about antiderivatives. So now we know how to differentiate. We would like to undo that. So basically, let's say, and in the beginning the book is very consistent. They say if f of x is x squared and I take a derivative, that will be 2x, or simply lower f of x is 2x. They use that in the beginning. They talk about capital F of x being the function and this being the derivative of it. Right there. Well, let's get one idea out of the way. If I had f of x equal x squared plus 100, then if I take a derivative of that, so assuming f prime of x equal that, again they're consistent in the beginning, that will be 2x plus 0, which is 2x. And if I wanted to find a derivative of, let's say, the original function happened to be x squared minus 30 pi. Well, 30 pi is a constant. When I take a derivative of this function, let's call it lowercase f of x, that will be simply 2x minus 0, which is still 2x. Now comes the tricky part. If I told you the derivative was 2x, and I'm trying to figure out where did this come from, you're going to tell me capital. So if I tell you lower f of x is 2x, where did this come from? Well, you're going to say, well, okay, so if I tell you f of x equal this, now, I'd rather we stick with this notation, but it doesn't matter. The book does that in the beginning, and we'll do the same. So capital F of x, you're trying to figure out where the derivative came from. Well, looking at this, you would know that, wait a minute, I must have taken the derivative of x squared to get to x, but here I had plus 0, if you want to think of it that way. Here I had plus 100, here I had minus 30 pi. So I'm going to say plus a constant. Now, what's the constant? It could be 0, that will be this case. It could be 100, that will be that case. It could be negative 30 pi, that will be that case. So every time you find an antiderivative, remember, derivative of constant is 0, and there's no way of figuring that out. So you always say plus a constant. So a function capital F of x is called an antiderivative of little f of x if, when I take a derivative of this, I get specifically that. So every time you do antiderivative, if you take a derivative of your answer, if I take a derivative of this, I should get that. So every time you take an antiderivative, the most general antiderivative is normally capital F of x, where the derivative of this gives you what they gave you, plus c, where c is an arbitrary constant. Now, we're going to get the power function out of the way. We know that if we take a derivative of x to the n power, where n is any integer, that's n, you bring the power down, subtract 1 from the power. If you want to undo that, if you're going backwards, if I told you that, so we have x to the n as being a derivative of a function, to undo that, to undo the subtraction, you would add 1 to the power and divide by the new power plus c. For example, if I told you that the derivative is 2x, what's f of x? The 2 we're going to ignore. You learn that in a bit. X isn't that 1 power? Add 1 to the power. 1 plus 1 is 2, and divide by that plus c. And there it is. Now, not to worry if you don't see this, because we're going to work this out on tons of problems. And let's get that out of the way. Here they're telling you they took a derivative and they get this answer. They want to know what would be capital F of x. Well, the deal is, just like when you take a derivative, you ignore the plus or minus. We're going to do the same here. And just like when you take a derivative or antiderivative, you ignore the constant. We're going to ignore the constant. We're going to apply what's known as the power rule, this rule, on x raised to a power. So here we're going to add 1 to the power, divide by that. That's what the rule says. Take this power, add 1 to it, and divide by it. And here we see it, and here we see it as well. So if I take this x, add 1 to the power, that will be 6 over 6. Don't forget the c for a constant. So you must have taken a derivative of x to the 5th plus, if you reduce the 2 and the 6, that's 2 over 3x to the 6 plus c. Now, at any time you want, finding the antiderivative is a lot of work, but taking a derivative is always easy. If you take the derivative of this, bring the power down, subtract 1 from the power, bring the power down, subtract 1 from the power, plus 0, 6 divided by 3 is 2, 2 times 2 is 4, you get back exactly what you started. So you can always check your work, you don't have to. That's where the answer is, but you could check your work. If I look at a problem like this, and I want to figure out what did you take a derivative of to get 1 over square root of x, I could say that's 1 over x to the, this is x to the 1/2, so if I move it up, so basically I'm making it a power function so I could use this on it. Then capital F of x will be add 1 to the power. Negative 1/2 plus 1 is 1/2 and divide by the 1/2. So we'll say capital F of x is, you know, dividing by a fraction, you multiply by the reciprocal. So if somebody was to say, what do you take a derivative of to get 1 over square root of x? You'll say, take a derivative of 2 times radical x, and we can check, you don't have to check. If I take a derivative of this, the 2 you ignore. Derivative of a square root is 1 over twice the square root of x plus 0. Those cancel out, and I'm left with 1 over radical x. And here the same deal. You could figure that out. That's x. Add 1 to the power. 1/3 plus 1 is 1 and 1/3, which is 4/3. And I would divide by that. Plus, now here we have 2x. We'd say 2 is not part of this. That's 2 to the 1/2, 2 to the 1/3, x to the 1/3. The rule only applies on variables. So add 1 to the power, 1/3 plus 1 is 4/3, divided by 4/3 plus c. And if you clean it up, instead of dividing, you multiply by the reciprocal. So that's 3/4 x to the 4/3 plus, that's 1/3, not 1/2. 2 to the 1/3 times 3/4 x to the 4/3 plus c. And that'll be my answer. So the notation for antiderivative is an indefinite integral. When you say what's the indefinite integral of little f of x, you're saying what did you take a derivative of to get this with respect to x? And there's the answer. We already said that. Now they remind you of few derivatives. This is forward, this is backwards. This is forward, this is backwards. That's how it works. You could look at those, you know, to remind you that derivative of tangent is secant squared, which means the integral of secant squared is tangent. Don't forget the plus c, and so on and so forth. These are all the derivatives we took. Now, if I take a derivative of e raised to the power of x, or if I take a derivative of the sine of some kx, where k is a constant, wouldn't this be e to the kx times k by the chain rule? Wouldn't that be the cosine of kx times k? So if I take a derivative, I multiply by this k. And if I take a derivative, I multiply by that k. If I integrate, I'll get e to the kx. If you take a derivative, you multiply. To undo that, you would divide. And that's an easy fix. So something to get used to, just like this problem. They took f of x to be, they took a derivative and this is what they got. They're trying to figure out what did you take a derivative of to, like sine. Derivative of sine is cosine. Derivative of cosine is negative the sine. Remember, we're going backwards. So if this is positive, I must have taken the derivative of negative the cosine of x to get the sine. I must have taken the derivative of negative the cosine of 2x. Now, if I was taking a derivative, you would multiply by 2. To balance that out, you divide by that 2. And that's the catch. And pretty much the rest is all the same. Now, if you want to see how these work, they're right there. Derivative of cosine is negative the sine. So the integral of sine, if you want to go back, you divide both sides by a negative. Every cofunction has that issue. You know, cosecant Derivative of cosecant is cotangent cosecant. So the integral of cosecant cotangent is negative that cosecant. You gotta write it out a few times to get it. Don't forget the c. And if I clean this up, I'll say capital F of x is negative twice the cosine of x minus cosine of 2x divided by 2 plus c. Now the good thing is you could always take a derivative of your answer and you should get what you started with. If I take a derivative of this, the negative 2 you ignore. Derivative of cosine is negative the sine. That gives you that piece. Here take the negative 1/2 out. Derivative of cosine is negative the sine of 2x times 2. The 2's cancel out and the negatives cancel out, and there it is. Same deal here. If I want to figure out what f of x is, I know that derivative of cosecant of x is negative cosecant of x cotan of x. So if I'm trying to work backwards, I simply divide by the negative. I'll say that is negative the cosecant of x plus the 3 I ignore. That's a power function. Add 1 to the power, divide by that, plus c. And there it is. So the part that I'm leaving out for now, and I'd like you to start writing, you want to write f of x is the integral of twice sine of x plus sine of 2x dx. Capital F of x is the integral. Now, if you don't write it for now, that's not a problem because pretty soon it's going to be written for you. And here it is. So here they're asking, what did you take a derivative of to get secant tangent? Obviously, secant of x, derivative of secant is secant tangent, plus 4, ignore the 4. What do you take a derivative of to get x? That's x to the 1, add 1 to the power, divide by that, plus c. So my answer is secant of x plus 2x squared plus c. If I take a derivative of this, if I take a derivative of that, that will be secant of x tan of x, plus bring the power down, subtract 1 from the power, and there it is. Same deal here. If I wanted to take the antiderivative of this, well, figure out where this came from. Let's see. What do you take a derivative of to get e to the x? E to the x. What do you take a derivative of to get e to the x? E to the, well, this is negative x. Since that's a constant, I divide by that, and that's the catch. So that will be e to the x minus e to the minus x plus c. Take a derivative of this, you'll get that. Sometimes they give you the initial value, all what it says when x equals 0, y equal 2, so that you could figure out what c is. So here, f prime equal this. So if I want f of x, I integrate. This is x to the 1/2. Add 1 to the power. Divide by that. Dividing by 3/2 is like multiplying by the reciprocal. Add 1 to the power, divide by that, plus c. So there's my answer. But since they gave me initial conditions, they said y equal 2 when x equals 0. Y equals a 2 when x equals 0. Well, that means 2 equals c. So I'll say cap f of x equal 2/3. Now you could write that as the square root of x cubed. If you wish, you could leave it like that. It doesn't really matter. And there it is. This is a function where if you take a derivative of it, you'll get that. And if you plug 0 in, you will get a 2. And that's all what initial value problems mean. Here's another one. Same deal. They tell us what the derivative is. Find me f of x. So f of x, or capital F of x, however you want to say it, but that's a derivative. Add 1 to the power, divide by that, x to the 4th over 4. Ignore the 8, x cubed. Add 1 to the power, divide by that. 16. Add 1 to the power, divide by that. And isn't 1 x to the 0? If I add 1 to the power, wouldn't that be x to the 1 over 1? Or what do you take a derivative of to get 1x plus c? So my f of x is x to the 4th over 4 minus 8x cubed over 3 plus 8x squared plus x plus c. If they gave me initial value problems, y equal a 0, when x equal a 0, it doesn't have to be 0, but in this case, that's what they gave us. Let me go back, and it didn't register the color. There we go. So 0 equal 0 to the 4th over 4 minus 8 0 cubed over 3 plus 8 0 squared plus 0 plus c. So c is 0. If c is 0, then I could write this without c. This problem passes through the origin. That's what that means. Oh, not plus. And there's my answer. And that's pretty much it. Here's another one. Find the antiderivative. Well, here I could say f of x equal derivative e to the negative 2x, e to the negative 2x. If I was taking a derivative, I'll multiply by negative 2. Antiderivative, you divide by negative 2. 3, add 1 to the power, that's x cubed divided by 3 plus c. So f of x is e to the negative 2x divided by negative 2 plus x cubed plus c. They gave me the initial values. They said y equals 0 when x equals 0. So I could say 0 equals e to the 0 divided by negative 2 plus 0 cubed plus c. 0 equal negative 1/2 plus c. That means c equals 1/2. So all what I have to do, come here and say f of x equals e to the negative 2x over negative 2 plus x cubed plus 1/2. And that takes care of business. Now, if you'd like to write e to the negative 2x as 1 over, you can. The rule of thumb is if you start the problem with a negative power, you could leave your answer with a negative power. And that's pretty much it for this section. This is a very short section. There's our homework.